welcome back to the lecture series in bioenergy. So, let us see what are the technologies which are currently being used and what are the relevance to the drawing which I made just underneath out here, where this comes very handy. Okay. So, now what are the technologies what we have in order to bypass the problems? So, we have to bypass the problem of bypassing or solving thermal problem, solving the problem of thermal stability, thermal instability and corrosivity. So, one of the ways, so you get a bio oil, okay. You have two routes. You can hydrogenate it, okay, hydrogenating. So, what is meant by hydrogenating? Hydrogenating is the process where you are adding hydrogen to it. By adding hydrogen, you are ensuring you are enriching it into a much more reduced condition. You are getting rid of as much oxygen as possible and you are reducing it further, all these different hydrocarbons to further reduction process. Okay. So, essentially out here what you are doing is you are adding hydrogen by hydrogenating, and the liquid which is formed, liquids which are formed are gone for the refining, further refining, and what you get out of this hydrogenation are products like naphtha and diesel. We will come later about these products, okay? Naphtha and diesel. The other route what is being followed is zeolite treatment. We will come soon on this topic. What does that mean? Zeolite treatment, and through zeolite treatment you do a refining following zeolite treatment, or you can do a further conversion in the form of to make olefinic gases, or once again olefinic gases, okay. And what you get out of this is you get high octane gasoline, okay, high octane gasoline, and you get fuel oils. And this process of zeolite, so you can basically classify them into two groups. So, if I had to summarize this picture or this flow chart, so you have the bio oil, and what you are essentially doing is you are removing oxygen as well as you are doing it by hydrogenation, and you are doing one more process, you are doing removal of alkali metals which is done further followed by catalytic cracking. So, I use some big terminologies here, we will come one by one. What does that mean? There are three new terminologies what I have introduced. I introduced a terminology here, zeolite. I talked about already about hydrogenation, hydrogenating. I talked about another term, catalytic cracking, and I talked about removal of alkali metals. Okay. So, now coming back where we started. If you remember, when we talked about the characteristics of the biomass, we went into in-depth detail about talking about different kind of ratios, and then in the end we talked about the ash percentage and alkali metals. So, most of these biomass comes with quite a good amount of alkali metals, and these alkali metals are another reason for increasing corrosivity, and most of these alkali metals are cationic in nature. So, what one has to do is one has to remove these alkali metals one step. So, there are two things we talked about. If there are trace amount of oxygen, that has to be removed. So, that could be done by hydrogenating it. You are pumping more and more hydrogen into the system and it reduces it further and further. So, if it gets reduces further the hydrocarbons, there is not much scope for it to get oxidized and convert it into some kind of corrosive materials. Okay, that is one step. The second thing is that these kind of materials are rich in, they have a significant percentage of alkali metals, that has to be removed. And while removing the alkali metals, there is another process which is followed, which is called catalytic cracking. What does that mean? So, now let us take a step backward. So, the first word what I have mentioned here is, if you remember, I told you about the zeolites. So, what does this word bring in your mind? What is a zeolite? Most of you in your day-to-day life are using zeolites. You have seen different kind of water purifiers where you have these cation exchangers, anion exchangers likewise. So, those are nothing but zeolites. What are zeolites and what is the literal meaning of it? So, it is very interesting. So, now what we will talk about, because we will, and once again to remind you, do not forget this picture, we will come back to this picture very soon. So, now coming back, what is a zeolite and what is the role of zeolite in ensuring that we are purifying the oil, bio oil, and making it free from these alkali metals. So, let us have a detour from this. So, at your house many of you get hard water, right? You pass it through a water purifier. What a water purifier does? When you talk about hard water, we talk about there are presence of alkali metals in the water. So, you pass it through a material where these different kind of, so for example, you have hard water and you pass it through a processor or through a material where all those alkali metals, say for example, if this is the water sample what we are talking about, okay, and you are funneling that water sample through this. So, this has lot of this residues of alkali metals what you see. Now, when the water goes through it, water comes out fairly devoid of those material, and those red dot what you see gets trapped inside material. This is how such filters are being made, and those filters are nothing but very unique three-dimensional architecture of atoms arranged in such a way with this very small pore size. So, what are those kind of materials? So, I will have to take you back to somewhere around 1756. Okay? That was the time when there was one element, you all have heard about nickel, right? There was a Swedish geologist who discovered nickel, okay? And his name was Axel Cronstedt. He is the discoverer of nickel in 1756. He was a geologist by training, and he discovered another thing, and as a matter of fact, he is the person who gave this name called zeolite, which is also called, which actual meaning is boiling stone. What does that mean? That means, suppose you have water, right? You give heat, you see steam coming out. So, you have rocks instead of water. You give heat, nothing will come out. But you have zeolites, a very unique form of mineral. You give heat, you will see steam coming out. What does that mean? It means there are materials which have formed on the earth crust far below, which traps significant amount of water molecules, and those water molecules, if you could pull out such materials or such minerals and just start giving heat to them, you will see water coming out of it. Having said this, I bring your attention to the picture what I drew out here. You see this rock, you remember? And I told you that it has lot of such cavities. Of course, I told you those cavities are filled with oil in the oil field, but there could be such material which could be filled with water also. So, there are such materials on the earth crust which deep underneath, which could trap a lot of water molecules in them. Now, having said this, let me put down some of the details about the zeolite, because this will come handy while we talk about the catalytic cracking. So, these zeolites are basically, these are hydrated aluminosilicate materials. Okay. These are hydrated aluminosilicate materials made up of interlinked tetrahedra of alumina, interlinked tetrahedra of alumina, or AlO4, okay, and silica, which is very abundant on earth crust, SiO4. Okay. In simpler words, if I have to put it, simpler words, they are, first point, they are solid with relatively open three-dimensional crystal structure, with relatively open 3D crystals with a lot of pores in them, as I have shown you, and built from, they are made from elements of aluminum, oxygen, silicon, and with alkali and alkaline earth metals. Such as sodium, potassium, magnesium, plus water molecules trapped in that such a structure. So, if you kind of try to visualize it, it will be more like something like this. It will be a structure of lattice structure like this, just for your understanding. So, it is kind of a mesh of different porosity, where you are having alkali metals trapped in them, and there are a lot of water molecules which are trapped in such structures. And it has some very unique properties. We will come to the properties. It can is stable at high temperature, very stable at high temperature. High temperature, approximately 1000 degrees centigrade, nothing is going to happen. These are stable at high pressure, and they can trap several cations. Cations could get trapped in that such. So, as a matter of fact, such material could be used as cation exchanger, and this is one property which is very widely exploited for making water purification with it. They can bind to a series of radioactive material. So, this is for water purification. Binds to radioactive materials. As a matter of fact, you will be surprised to know, all of you have heard about the Fukushima disaster in Japan, the leakage in the nuclear power plant. So, in and around Fukushima region, the farmers in the field, in the paddy field, they use different kind of zeolites in order to trap the radioactive materials which got leaked out and contaminated the soil. And apart from it, most of these zeolites are used to clean the areas where there are radioactive contamination. So, apart from it, there is a third property these have, come to that. So, these pores acts as very similar to, so this is a kind of hypothetical structure which I drew. These pores are very similar to something what I drew out here. They are almost like series of small test tubes or reaction vessels which are there. And so, coming back, so these are small reaction vessels. So, if anything which gets trapped into them, so zeolite as reaction vessels. We will come to this, what is the significance of it as reaction vessels, as I just put infinite number of reaction vessels. So, before I come to this reaction vessel concept, which is of direct significance. So, there are two things which are of direct significance to us in this aspect. One is the catalytic exchanging property, or in other word binding to cations. This is one thing which is important for us, and second thing, zeolite as a reaction vessel. These are the two aspects what we will be going to deal with, which is of our direct concern for bio oil purification. So, before we get into that, what are the different kind of, through, as you know, through geological eras we have different kind of rocks which are formed, igneous, metamorphic and sedimentary rocks. Okay? And in most of these rocks, whether it is a sedimentary or most of the igneous, which are the volcanic ones, volcanic or sedimentary rocks, through sedimentation, you will see at least there are 40 different kind of zeolites which are formed. Okay? And the example are cabazite, 40 different natural zeolite. Okay. Some examples are cabazite, then clinoptiolite, mordanite. Okay. Whereas there are at least 150 artificial zeolite which has been made. A stands for artificial, which has been man-made zeolites which are there. Like you have zeolite A, which is used in laundry detergent. Okay. Then you have zeolite X and Y, which is also called phogosites, which is used for catalytic cracking. We will come to this, what is this catalytic cracking is all about. Then you have ZSM5, these are all which is used in the petroleum industry. Okay. Now, having giving you a brief idea about zeolites, it is a vast subject. So, our concern, as again to reiterate, is this part, what this catalytic cracking is all about. Now, coming back to where we left. So, now we know what is a zeolite. Now, these zeolites are being used for removal of the alkali metals. We have talked about it. So, they have cation exchanging ability and they could be used for removal of the different kind of materials, different kind of alkali metals which are present there. Second is the last one is the catalytic cracking. So, what happens when we are flash pyrolyzing the biomass in order to make bio oil? So, when you are doing in the laboratory conditions, there are 2-3 things which happens. One is there is still some oxygen left out there. So, that could be removed by a hydrogenation process, what you have already talked. There will be a series of alkali metals which are present there, which along with residual oxygen and likewise will create a lot of problems, will form corrosion, will form deposits, scaling on in the engine, which will damage the engine. So, those could be removed by passing the oil, bio oil through a zeolite, but that zeolite does something more. As I have told you that zeolite has 3 or 4 very unique properties. If you remember where we talked about the zeolite here, If you come back to this, so see, they are stable at high temperature. This is one critical property. They are stable at high pressure. This is a second property. In other words, this particular stuff is a very good matrix for a reaction to happen, because you can do any kind of reaction at a high temperature and high pressure. So, one of the challenges what these through flash pyrolysis, the problem which is being faced by us is there are a lot of hydrocarbons which remain in a long chains. So, now what is being done? These long chain hydrocarbons, when they are moved through the zeolite, they get trapped into these small pockets, which are, as I told you, they are like that picture what I showed you last class, as if, say for example, you have the oil, you are pushing it through this and they are getting trapped into these lot of these test tubes. Okay. And now you are having a high temperature, you are giving it because they are stable at high temperature. Okay. Now, out here what is happening, what you are deriving out of it is in those small vessels, those long chain hydrocarbon gets broken down into fragments. In other words, you are using zeolite for catalytically cracking the hydrocarbon, long hydrocarbon chains into smaller fragments, and by breaking them down, you are increasing the fluidity of your oil, because solid particle is like potentially longer chain will make it more solidifying, where you are cutting it in small pieces. So, you will have lesser blockage, you are increasing the fluidity and mobility of the oil, and on top of that you are able to catalytically crack all those bigger chains. So, that is why that word came, catalytic cracking of the oil. Okay. So, we will talk a little bit more, we will close in here and we will talk a little bit more in the next class about this catalytic cracking and how that is so very helpful. Okay. Thank you.